Good morning to the session. Now first you take down this question and then we will try to solve it. A rectangular coil of area A having number of turns n is rotated at f revolutions per second. F revolutions per second in a uniform magnetic field B. In a uniform magnetic field B, comma, the field being perpendicular to the coil. The field being perpendicular to the coil. Prove that the maximum EMF induced in the coil is 2 pi f NBA. A rectangular coil of area A having number of turns n is rotated at f revolutions per second in a uniform magnetic field. You can take in a uniform magnetic field B. The field being perpendicular to the coil. Prove that the maximum EMF induced in the coil is 2 pi f NBA. Now this is very similar to the principle which we use in AC generator. So now here, to calculate the induced EMF, we should know the change in magnetic flux. So first we have to calculate the magnetic flux. So why the magnetic flux is changing here? Because due to change in area swept. Why? The coil is rotated here in the magnetic field. As it rotates, the area swept keeps changing and hence the flux linking the coil keeps changing. And this is very similar to the one which we have seen in the case of AC generator. The change in area here produces change in flux and hence that gets an EMF induced. So if the coil is rotated with an angular velocity omega, then we know that the flux linking the coil is given by, or you can write, let coil rotates by an angle theta with the magnetic field in time t. That the coil rotates by an angle theta, or initially let us take the area vector E of coil makes an angle theta with the direction of magnetic field. So this is something similar to this. Now if you take a coil, okay, so the coil is rotated something like this. So initially let us say the angle between B and T is theta. Let initially the angle between area vector A and magnetic field B is theta. As coil rotates, that theta keeps changing. Therefore, we can write 5 as BA cos theta. Now, if the coil is rotated with an angular frequency omega, then you can write it as the flux linked with each turn of the coil as BA cos omega t. So for more explanation about this, you may refer the previous video. There we have clearly shown, like, how it becomes BA cos theta, BA cos omega t, etc. Now the induced EMF E is minus d phi by dt. This is by Faraday's law. Minus d by dt of BA cos omega t, or E is minus BA into d by dt of cos omega t, and we know the differentiation of cos omega t is minus omega into sin omega t. So this will become BA omega into sin omega t. Now if the coil has a number of turns, that is given, the coil has a number of turns, right? See, the coil has a number of turns. You can write, instead of if, given that the coil has a number of turns. Therefore E is equal to n into BA into omega into sin omega t. This is the EMF induced in one turn. If there are n turns, then EMF induced is given by nBA omega sin omega t. Now omega is 2 pi f, because it is given that it makes f revolutions per second, right? Frequency. The coil is rotated at f revolutions per second. Given the coil is rotated at f revolutions per second, therefore also omega is 2 pi f, where f is revolutions per second, and hence you can write E is nBA into 2 pi f into sin omega t, and this value is the maximum value of induced EMF, is EM. E is EM sin omega t. E is EM sin omega t, where EM is 2 pi f into nBA, 2 pi f into nBA, and it is the peak value, and EM is the maximum value of induced EMF. Because we know the sine equation or voltage is always written as EM sin omega t, where EM is the maximum or peak value of EMF induced. So EM is the maximum value of induced EMF. Hence the proof. EM is 2 pi f into NBE, and this is the proof required, because we are asked to find out that the induced EMF is 2 pi f NBA, and we finally got 2 pi f NBA. 2 pi f NBA. So this is the value of induced EMF. Hope you understood this problem.